See if I can wrap up chapter 5 here today. So last we left off, we were talking about we had talked about cost structure, and we said that when we graph fixed cost, it goes in as a horizontal line. So if we're graphing dollars in revenue and costs on the y-axis and volume or quantity, you can do either one on the x-axis, then fixed cost, right, is fixed with respect to volume, right? That is by its definition, it doesn't change with volume as long as we're within what? Relevant range. Thank you. So you want to remember that term, as long as we're within the relevant range. Then we said, okay, when we start looking at total cost starts at the fixed cost and goes up with a slope equal to the variable cost per unit. Right? And this gap is the total variable cost, because fixed cost plus total variable cost gives us total cost. So the total cost curve starts at where the fixed cost, where fixed cost touches the or crosses the y-axis, or where fixed cost is the intercept, and then the total cost line goes up at a rate equal to the variable cost per unit. Then we started to talk about revenue under fee for service. Right, so this is fee for service revenue, and fee for service revenue, drawing it separately, right, is some price, and so we're treating, in reality, if you were running a practice like we looked at when we looked back in chapter 2, we looked at how much is billed per visit. You know, it depends on the intensity of the visit. It depends on what the physician or other provider does during the visit. All those things drive the individual price per visit. For this chapter, we're just going to pick a kind of average price per visit, and then we'll use that one price. But in reality, it's more complicated than that. So you just kind of want to hold that in your head. So when we talked about when we talked about fee for service, we said, as volume increases, we see more revenue. And so the incentives under fee for service are to drive greater volume. And so we said, okay, if we're graphing price times volume, then total revenue increases constantly with a slope equal to P. Right? So if it's $100 per visit, if the revenue is $100, the price is $100, then for one visit you get $100, 2 visits they get $200, 10 visits they get $1,000, so on, right? It's always volume times the price. So that's going to give you a straight line going up. Then we said, all right, if we bring these two things together, we now have our graphing here, our revenues and our costs together. And so we now need our profit function. And I'm going to use the Greek letter pi, right, to represent profit. So this is going to be profit. Okay, so profit equals total revenue minus total cost. Okay. So profit equals total revenue minus total cost. Now, we know that from chapter 3, when we did the income statement. We said we have our operating revenue minus our operating costs give us our income. That's what profit's just, we're just using another word for income. Okay, so this is not new. And then we can break that out and say, okay, total revenue is equal to P times V. minus total cost, right? And total cost is fixed cost plus total variable cost. And we can make that more specific. And we can say P times V minus fixed cost plus variable cost times volume, right? So that's kind of the expanded definition of profit. We can graphically represent profit here, though, and say, all right, if this is total revenue, this is total cost, then if I pick an arbitrary number, say here, and I'm just doing it graphically, and draw a line up from this volume, V1, we'll call it. I draw a line up from V1, the volume at this volume, this is how much revenue I have, and this is how much cost I have, right, at V1. And so what you can see is the cost is larger than the revenue. So this gap would represent a loss. I have more cost than I do revenue at this volume. Now, what happens as I move here to V2, right? I'm moving along to V2. I still have more cost than I have revenue, right? Because I'm drawing a line through. But what has happened as I move from V1 to V2 in terms of the gap? What's happening to the gap between my total cost and my total revenue? It's getting smaller, right? Okay. Then I hit this point here, this crossover point, right? This crossover point is a special point. The point where these two lines meet is our break-even volume. So at that point, that's our break-even volume. I thought I had a green marker. Don't. Go with blue. So at the break-even volume, my total cost and my total revenue are equal. So if I plug if total revenue and total cost are the same number, let's say they're 1,000 and 1,000, that gives me a profit of what? 1,000 minus 1,000 is 0, right? So at that point, I have 0 profit. So at volume 1, where my total cost is greater than my total revenue, I have a loss, right? In this case, my total revenue is less than my total cost. So this number is bigger than this number. So now I have a negative number here. That's a loss. At V2, I have total cost greater than total revenue. And so again, I have a loss. When the total cost curve is greater than the total revenue curve, all of these points to the left, right? All of the points to the left of the break-even point are in the zone, what I call the zone of loss. Okay. All of the points to the left of the break-even point are a zone of loss. And you can just look at that and you say, okay, which line is on top? Is the total cost line on top or is the total revenue line on top? And everything to the left of the break-even point, the total cost curve is above the total revenue curve, which means that for any one of these volumes, the total cost number is greater than the total revenue number. And so we have a loss, we have a negative profit. Now, when we hit the break even, they're exactly equal, which means that profit is now equal to 0. So we've gone from negative numbers here to 0. And then here, let's call that V3. I now have a situation where my total revenue, remember, I'm always going to draw a straight line up from the volume axis up through the two curves to test, am I making a profit or not? And here I'm now making a profit because total revenue is above total cost. And if I go out here, right, that gap just keeps getting bigger. And so the farther I go out to the right of break even, I'm in the zone of profit. Bless you. So everything to the left of the break even volume is loss. Everything to the right of break even volume is profit. All right. Let's do an example with numbers now. So, well, let me hold on for a second. What I want to do now is do the math behind this. So what I need to do is put in numbers for these two curves, okay? So I'm going to fill these in. So let's go back to our lab example that we were doing. We said that the fixed cost, remember our fixed cost for our lab was we had $50,000 for the machine and $50,000 for the lab tech, right? For a total of $100,000. Then we said that the variable cost was $10 per test. And we said that the relevant range was 20,000. Now, let's assume that we can get a price of $50 per test. So we're under fee for service assumptions. All right, so now we have all the information we need to calculate what the break even volume would be. Now, what condition did we say is true here at the break even with respect to total revenue and total cost? At that point, what's true about total revenue and total cost at that break even point? Emma, they're equal. Total revenue equals total cost. If this number and this number are the same, what value am I going to get for profit? 0, right? So the break-even condition is going to be where profit equals 0. Okay, so now we really have all the information we need. If we're going to try to calculate what the break-even volume is, we know that profit has to equal 0. So we're going to look at this line here, okay? Because this is the most broken down. So we know that the P is 50. We don't know, we're trying to calculate volume, so we're going to leave volume there as a variable. Minus, we know that the fixed cost is 100,000. We know that the variable cost per test is 10. So that's it. That's the setup. So now we just solve for V. Okay. So the first thing you do is you want to take this negative and distribute it through the parentheses. So 0 equals 50V minus 100,000 minus 10V plus 10V. Right. Sorry, it should have been minus. This should be 100,000 minus 10V, and then it becomes minus 10V. There we go. All right. Then we're going to consolidate terms. So running out of space. So 0 equals 50V minus 10V. 0 equals 50V minus 10V is 40V minus 100,000. Add 100,000 to both sides. We get 40V equals 100,000. Then we get V 100,000 divided by 40 gives us a V of 2,500. Okay. So what does that mean? Well, let's put this on a graph now. What's the slope of the total revenue curve? Total revenue is price times volume. So what is the slope of the total revenue curve? 50, right? It's the price, whatever the price is. So this is 50. How much fixed cost do we have? We said 100,000. What is the slope of the total cost curve? Said it a minute ago. What? 10. It's the variable cost, right? The slope of the total cost curve is the variable cost. All right, set it up here. Slope of the total revenue curve is the price, because the total revenue curve is price times volume. Total cost curve, the slope of the total cost curve goes up at a rate of the variable cost. So in this case, variable cost is 10 per unit. Right. So the break-even volume, we just said, is 2,500. What is the break-even revenue and total cost? Well, 2,500 times, if total revenue is price times volume, and we said that it's 50 at the break-even point, 50 times 2,500, then that gives us 125,000. So at 2,500 units, the revenue is 125,000. Total revenue is 125,000, and the total costs are 125,000. Think about that for a second. Total cost is fixed cost plus the total variable cost. The fixed cost is 100,000, and 2,500 units times 10. 2,500 times 10 is 25,000, right? So 100,000 plus 25,000 is 125,000. So we kind of checked that in our heads. So total revenue, right? Total revenue at 2,500 was 2,500 times 50, 125,000. Total cost at 2,500 is 100,000 in fixed costs plus 10 times 2,500. That's 100,000 plus 10 times 2,500 is 25,000. That gives us 125,000. So at this point, your total revenue is 125,000. So we have profit. Total revenue is 125,000 minus total cost of 125,000 gives us 0 profit. So if we're running this lab with this cost structure and this price, we know we've got to do at least 2,500 tests in order to break even, right? So if we want to make a profit, we have to do something more than 2,500 tests. If we make less than 2,500 tests, anything less than 2,500 puts us into the zone of loss, where the total cost curve is above the total revenue curve. Anything to the right of the zone of 2,500 puts us where the total revenue curve is above the total cost curve for any volume. So as I look at the volume, because in fee for service, volume drives everything, right? I'm using my Sharpie to indicate the relationship between total revenue and total cost at any given volume. And so as I move my Sharpie over to the right and I'm choosing this relationship, right, I have total revenues greater than total cost. All right. So what is the lab's profit at 10,000 tests? We know that they can do up to 20,000. So what's their profit at 10,000? You figure that out. Go ahead. Here's the formula. Here's your data. I'm telling you now that volume is 10,000. So it's just a matter of plugging in the data. So instead of solving for volume, I'm giving it to you. You just need to tell me what the profit is. 10,000, a volume of 10,000. So we know from the graph that we're out here someplace, right? Which means that total revenue is greater than total cost. We're going to have a profit. I'm just wondering how much it is. Yep. All right. All right. So we know profit equals price times volume. Price is 50. The volume is 10,000 minus the fixed costs, which we know are 100,000, plus the variable cost, which is 10, times the volume, which is 10,000. Right? So 50 times 10,000 is 500,000 minus 10 times 10,000 is 100,000. So 100,000 plus 100,000 is 200,000. So 500 minus 200,000, 300,000. Everybody get that? We following? Shayla, got it? All right, good. John? All right. All right. How about what's their profit at 2,000 tests? So same thing. Now put in 2,000 tests. What's their profit? I will give you this formula on the exam. So you don't have to memorize it, but it's not a particularly complicated formula. And so you should do enough problems where this just kind of blows off your head. But I will give it to you in case you have a freak out on the exam. So 2,000. So now we're just plugging 2,000 in for volume. All right. I'm just going to go ahead and do it. So still $50 times 2,000 now, minus 100,000 in fixed cost plus 10 times 2,000. All right. 50 times 2,000 gives us 100,000 minus 10 times 2,000 is 20,000. So 100,000 plus 20,000 is 120,000. So 100 minus 120 is negative 20,000, which is consistent with our graph, right? Because a volume of 2,000 would put us over here someplace where we see that the total cost curve is above the total revenue curve at this volume. And so we have a loss, right? Okay. Let's do a different example. Let's assume we have a clinic. And that clinic has 500,000 in fixed costs, $25 per visit in variable costs, and the average price per visit is $80. I want you to write out its cost structure. In other words, what's its total cost function? Write out its total revenue function, then write out its profit function, which is the combination of the revenue and the total cost function or the cost structure. So let's start with that. And yes, this is a fee-for-service clinic. I haven't changed that up yet. Pass that back to Linda. All right, let's start with the total cost function. Total cost right? Total cost is equal to fixed cost plus total variable cost. And total variable cost is equal to variable cost times fixed cost. So total cost is fixed cost plus variable cost times volume. So what is fixed cost? 500. Variable cost. So we'd have 25V. So total cost equals 500 times 500,000 plus 25V. Total revenue is price times quantity, price times volume. So price is 80. So that's easy. It's total revenue is 80V, right? Now, the profit function is total revenue minus total cost. We said total revenue is price times volume, or 80V. Total cost is 500,000 plus 25V. So 500 plus 25V. So that's our profit function for this lab, for this clinic. All right. Give me their break-even volume. What do I have to do to get the break-even volume? Molly. Right. I'm going to set profit equal to 0. Break-even volume happens where profit equals 0. So I'm just going to set this function equal to 0. Then I just solve for V. And from there, it's just algebra. It's a little bit of a funny number, so don't freak out if you're like. It's harder to like make up examples that come out with like nice clean numbers than it seems like it would be. Okay, so profit equals 0, 80V minus, I want to distribute the negative, right? Then I'm going to consolidate like terms. Then I would add 500,000 to both sides, divide through by 55, and I'm going to get what? $9,099 units. And I'll do that in a second. I want to make a point. Let's look at this, where we're at with this function. We haven't put a volume in yet. In fact, we haven't done anything with the left side at all, other than saying that it's going to equal 0. So let's ignore the left side for a second. Let's ignore the 0. We could have just left the pi there as I could have just carried the pi down. The profit is equal to 500,000. Right? Does that, you guys follow me? I could just say, all right, I haven't done anything with this left side. I could have just done the consolidation of terms and said profit equals 55V minus 500,000. And you say, well, why would you do that? And say, well, because I want to make a point. And the point is that 55V, think about it. If volume goes up 1, what happens to profit overall? Well, nothing happens to fixed cost, right? It's just staying the same. right? That's just going to stay 500. So as volume increases, as we go from say 0, at 0, what do we have? Profit of, let me actually change that. All right, so we have pi equals 55V minus 500,000. All right, now you can just, don't get hung up on the 0. When volume, just looking at this equation, when volume equals 0, what does pi equal? Minus 500,000, right? When I get 1 unit in, don't bother with the math, but like when I get 1 unit in, what happens to profit? Does it go up or down? When I get 1 unit of volume? Molly, it's going up, right? By $55 for every unit that I get, every unit of care that this clinic does, profit goes up by $55. At a very low number, that's still a big negative number, right? So at 1 unit, that's 500,000 minus it's 490, 499,945. Is that right? Yeah. Right. So it's still a really big loss, right? If they do 1 unit, they're still losing a ton of money. But if they do 2 units, they're losing a little less money. 3 units, they're losing a little less, and so on until we get to the magic break even of what we said was 9,099 visits. Then the left term, the 55V, is going to equal $500,000. Because what you told me was at 9,099 visits, probably in some change, right? 9,099 times 55 is going to be approximately equal to 500,000. So we'll get to that point where it's 0. And then if we go to 9,100 visits, we're now making a profit. So this combined number, this 55V, is the combination of the revenue per unit and the variable cost per unit. This number is what we call the contribution margin per unit, or in this case, per visit. So this number has a name, and it is the contribution margin per unit, in this case, per visit. So the contribution margin is going to be, and I'm going to abbreviate that CM, is going to be the revenue per unit, right, or revenue per unit of volume, minus the variable cost per unit of volume. So this is the contribution margin per unit of volume. Is going to be the revenue per volume minus the variable cost per volume. So in this case, that is the price minus the variable cost per unit of volume. And we said that the price is 80 and the variable cost per unit is 25. That gives us a contribution margin per unit of 55. Okay. Sorry, covered that up. So this is the contribution margin per unit is going to be the revenue per unit minus the variable cost per unit. So now we can do I'll go back to doing this, solving this. We're going to have more to say about contribution margin in a second. But basically what we're saying is, so this contribution margin is the aggregation of the price that we're getting minus the variable cost. So it's the variable component of what we're doing. The fixed costs are fixed. So each time we do an additional unit, we're moving toward covering all of the fixed costs and increasing profit. So 55 So when profit is equal to 0, 55V minus 500,000, right? I get 500,000 equals 55V. I divide through by 55, and I get V is equal to 9,099. Right. So the break even for this particular clinic is 9,099. So now draw the graph. This graph is called the cost volume profit analysis. So let's draw the graph, get our facts back. And we said the break even is 9,099. 9,000. All right. 9,090. Sorry. I'm working off my notes. 500 divided by 55. 9,090. Oh, sorry. That's my note was 9,091, and I'm seeing a 9. All right, 9,090. Let's call it 90 or 90. Well, really 90. It should be 91. So that's what I did before, and that's why I was seeing a 9. 9,091 because it's 9,090.9. So 9,091. So you're going to draw the cost volume profit analysis, which is this graph. So we're going to start by drawing what? Fixed cost first thing on. All right, so put your fixed costs on. Then you're going to add your total cost curve, which has a slope equal to the variable cost per unit, right? Then you're going to add your total revenue curve. Here's my fixed cost. My fixed cost is 500,000. My total cost goes up with a slope of 25 because that's my variable cost. The gap here is total variable cost. Then I draw my revenue curve. What's this? What's that volume? 91. 9,090, 9,091. It's not 9,099 apparently. Okay, well, I'll go with that. And that's what do I call that? The what? Break-even volume. Our friend Bev. Break-even volume. And in this case, that's 9,091. 9,090.909090. Okay. Where is the zone of loss? Molly. Good. Where's the zone of profit, Sean? Good. This area here is my loss, right? Because at any of the, if I draw a line from any volume less than 9,091, when I draw that line up from say 8,000, it's going to go through the total revenue curve first, then the total cost curve, and this gap is my loss. If I'm over here to the right of Bev, say 10,000, my total cost is less than my total revenue, and so this is my profit. All right. Yep. Either one, right? So good point. Okay, so if I want to draw, thank you, actually, that's a good point. So if I want to know how much is that, by the way, right? I take 9,090.9090909, right? Or we can round to 9,091, it's close enough. And we would plug it back into either our total revenue function or our total cost function. Total revenue function is easier, it's just times 80. So that we can know what dollar amount is the break-even dollar amount, where we're going to have zero, neither loss nor gain. So how much would that be? Well, 80 times 9,091 is 727,280. So at 9,091, we would be bringing in $727,280, and we would be spending $727,280. So we would be breaking even. Okay. All right. Now we can build, using this information, we can build a little basic P&L structure. Now, this is not how P&Ls actually look. And I'm not really sure why we call it P&L, because it's not. But for our basic P&L structure for this chapter, we're going to say, what's our total revenue? And this is for our cost volume profit analysis. What's our total variable cost? That gives us our total contribution margin. So total revenue is price times volume. Total cost is variable cost times volume. That gives us our total contribution margin. So in this case, we can rearrange this. If we say, right, because this is price times volume minus variable cost times volume. So if we say total contribution margin is equal to price times volume minus variable cost times volume, well, we can rearrange this a little bit, and we can pull V out, and it would just be P minus VC. All right, it's a little bit of, what is that, like 6th grade algebra. I'm pulling out this common multiplier. So volume, so price minus variable cost. And what was this? This is the contribution margin per unit, right? So what we said a minute ago, 80 for this particular clinic, 80 price was 80, variable cost per unit is 25, 80 minus 25 is 55. So in this particular case. So total contribution margin is variable cost, volume times price minus variable cost. That gives us our total contribution margin. Then we take away our fixed costs. And that is what it is. And that gives us our profit. And this structure allows us to kind of analyze how sensitive our organization is, how much we're bringing in each time we do a unit of care, and how sensitive our organization is to fixed costs. So let's plug in our clinic example. Okay, so at the top, we have 80V, then variable cost, 25V. Total contribution margin is V times 80 minus VC, or 55, which I could have just said was 55V. Our fixed costs are 500,000. And that gives us our profit. So subtract. All right. Let's think about our clinic for a second. So let's do a volume analysis for our clinic. So we have total revenue, and let's assume we have 5,000 visits, 9,091 visits, and let's go with 20,000. Let's go with 15,000 visits. 15,000 visits. So total revenue is going to be 80V, right? So 80 times 5,000 is 400,000. Total cost is total variable cost is 25V. So 25 times 5,000 is 125,000. Our contribution margin is 55V. So our total contribution margin. And here you could say, all right, 55 times 5,000 is 275. Or you could say 400 minus 125 is 275. You're going to get the same answer either way. Then our fixed costs are 500. And so our profit is 275 minus 500, 225, $225,000 loss. Right? You do the middle one. You do the break even. So this is our break even. Now, if you were doing this for real, you'd do it in Excel and it would take you 3 seconds, right? But we're doing it by hand because we're in class. You're repeating the same logic. Total revenue now at 9,090, a volume of 9,091. And it's going to be, there's going to be some rounding error here, but this is our break even. And if you get that, then do the third column. So if this is clicking, keep driving. All right. For the sake of time, let me keep going. So 9091 times 80. 727, 280. 9091 times 25. 227, 275. This is where the rounding is going to come in, I think. Minus 727, 280 gives us, 505. And so then we have 500,000, right? So we're essentially zero. This is the reason I have this extra $5 is because these should have offset such that this came to zero. If I did 500,000 divided by 55, right, times 80, I would get 727,272. If I did 500,000 divided by 55 times 25, I get 7. You can see it is more. It gets to exactly equal to 500,000. Then we would subtract. So that a little bit of rounding there. All right, third column. So this is our break-even volume, right? So this is loss. How do we do at 15,000? What's total revenue? Who's got it? Emma. And total variable cost. So 1.2 million minus 375 gives us 825. And if I instead did 55 times 15,000, I also get 825, right? Minus 500,000 because our fixed cost is fixed. It doesn't change. Gives us a profit of 325. So we did 3 examples of one in the zone of loss, one at the break even, with a little bit of wedge for a rounding, and then one in the zone of profit. So anything to the right of 9,090.09090909, right, is going to be is going to show some profit. Anything to the left of 9091 is going to show loss. Looking at the contribution margin. The contribution margin is the amount, right, is the amount of of value brought into the organization that can initially be applied towards covering fixed costs and then is applied towards profit. You could say that the break-even function is fixed costs equals, so this is a shortcut for break-even calculation, is price minus variable cost times volume, right? In other words, contribution margin times per unit of volume times the volume. Let's test that. If 500,000 equals 80 minus 25 times V, well, that's 55V equals 500. And we're back to where we got to with our initial solution. So 500 divided by 55 gives us our 9091. So if you want, and some students find it useful, you can memorize that, because I will ask you a break-even question on the exam. So if you want, you can memorize this: fixed cost equals price minus volume times volume. But you can also just solve for that using the total cost function. So there's no reason to memorize it unless it just helps. If it helps you, feel free. Yes. That's a shortcut for break-even volume. This is total contribution margin. So what's true is, if you look at, setting aside the little $5 error we've got from rounding, what's true is at break even, total contribution margin has to equal fixed cost, right? Now, organizations don't go into business to break even, right? You don't start a business so that you can make no money. You start a business to make money. So when we think about this particular firm, we can think of, they could set a profit target, and we could think of that profit target as if it were a fixed cost. So it kind of functions like that. So let's look at that. So if we said, instead of, where like here, where we're saying, hey, we want to break even, so we're going to set profit equal to 0. What's the volume we need to break even at? Well, that's nice to know. But like I said, nobody gets in business to break even. You get in business to make a bunch of money, right? So if we could take this same function and say, what we want to do is we want to target making $100,000 in profit. So how would I do that? If I want to know how many visits I have to do in order to get $100,000 in profit, what could I do here? What would I do here? Given I know this is my profit function, I want to make $100,000 in profit. I'll set what equal to, Molly, go ahead. Huh? Set profit equal to 100,000, right? So instead of setting equal to 0, where I'm going to make nothing, I want to make 100,000. So, all right, 100,000 equals 80V minus 500,000 plus 25V. Right? So that's 100,000 equals, we already know this, 55V minus 500,000. Right? Add 500,000 to both sides, I get 600,000 equals 55V. Right? Divide through by 55. I get 10,900. $10,909. Let's call it that. So in order to make 100,000 in profit, I just set profit equal to 100,000. And you could think of it, and when you're solving this equation, it's almost like we basically increased the fixed cost, right, for the organization, such that the in order to make that, I had to generate more contribution. Okay. So we could do these sorts of tests all day long. Now, we've been working with fee for service. I want to talk now about capitation. All right, we've talked about capitation before. You've talked about it in 401. You've talked about it probably in management at this point. What does that mean? Capitated payments versus fee for service payments. What does that mean? DeLuna.
Patients just paying the provider like a specific amount of money to do this instead of like fee for service, like per service.
You're in the right track, but you're still using the fee for service language. Who can help DeLuna? Emma. Right. So we blend together what DeLuna Emma said. Fee for service, I'm paying you per service. Capitation is per head. Kappa meaning head, right? Capo is head. So you pay per head rather than per service. So what does this mean? Well, if I get some let me see. Instead of paying per visit, the insurance company will pay a per member per month PM fee to the provider. The provider then provides all of the services contracted for by the insurance company. So for example, let's imagine our clinic that we were just messing around with is a family medicine clinic. And it's here in Durham. It's the Durham Family Medicine practice, right? And Cigna, the primary insurer, says, all right, family medicine, Durham Family Medicine, we have 2,000 faculty members that live in the Durham area, and we're going to assign them to your practice. And we're going to say, we're going to pay you $25 per member per month. You're going to get then a monthly payment of 2,000 times 25, $50,000. And if you want to get and that becomes pretty simple. So that's your monthly revenue. So 50,000 times 12, 600,000. Yeah. 600,000. I was want to say 6 million, 600,000 would be your annual revenue. For that $600,000, you have to provide all of their primary care. So if they come a little bit, you get 600,000 and you're probably not going to have to spend 600,000. But if they come a lot, that might exceed your 600,000. It's up to you. You've got, all you get is $600,000. So let's look at their incentives now. So we said they had 500,000 in fixed costs. They had a total cost curve at 25. And now we're saying under fee for service, they would have got $80 per visit, right? But we're saying instead of giving you a fee for every time these people come in, we're going to cut you a check each month for $50,000, whether they use your services or not. So the revenue is no longer tied to volume. The revenue now is a fixed revenue. So the revenue now, because it's no longer tied to volume, what does that look like if I draw it on here? It's not going to vary with volume. Capitation is not a cost. It's the way you get your revenue. But it is fixed. The idea is it's fixed. It's not tied to volume. It's tied to the number of members that you agree to cover. So we said we're going to have 2,000 members and they're going to get 25 and the insurance kind of Cigna is going to pay Durham Family Practice $25 per member per month for a total of $50,000 per month or $600,000 per year. How am I going to draw the revenue, the new revenue curve, Molly? Above fixed costs at how much? I just said it, 600, right. So the new revenue curve, and I probably should have picked a bigger number. The total revenue is a horizontal line, right? Why is it a horizontal line? If you do more volume, you don't get more money. If you do more volume, you do incur more cost, though. Every time you see one of these patients, it's going to cost you $25, 25 additional dollars, right? We made it up. That's the fixed cost, right? That's the fixed cost we've been working with, and I just made that up. It would be whatever it is, right? So it'd be a combination of rent, salaries, insurance, so forth. I would go into that. So I just picked a number to represent it. So I'm getting $600,000. The beautiful thing about capitation is I'm getting $600,000 whether I see 0 patients. So just like fixed cost, right? I have a fixed $500,000. I've got to pay my rent. I've got to pay my salaries for my clinical staff and my administrative staff. All of that is completely independent of the number of visits that I do. Now, what's also independent of the number of visits I do is my revenue, because I've got a contract with the insurance company that says, here's your 2,000 patients, take care of them, and I will give you $600,000. Here's the hitch, right? Where's the break-even point? Well, the break-even point is where total revenue crosses total cost. Under fee for service. So this is still our break-even volume. Under fee for service. To the right of break-even is my profit. To the left of break-even is my loss. Is that still true? How do you know? You're going to draw a line up from volume. And you're going to see where it where the lines, where the volume line crosses each of the revenue and cost lines. So here at this line I just drew to the left of the break-even volume, so below break-even volume. What's the first line that my volume line crosses? Cost or revenue? Cost. Then it crosses revenue. So that means that revenue at that point there, let's call it volume 1. At that point, total revenue is above total cost. Right? Here's total revenue. It's above total cost. This is supposed to be a horizontal line. I think it's a little curvy. It's supposed to be a straight line. So total revenue is above total cost. So that means at V1, total revenue is greater than total cost. So that means profit is greater than 0, less than 0, at 0. We don't have any specific numbers here, so you can just tell me, are we making a profit? Or we have a loss? Or are we breaking even? A loss? Making a profit? All right. Brianna, why are you saying we're making a profit? Revenues are right. So our total revenues exceed our total costs. That means there's money left over for profit. Just throwing in some arbitrary numbers for revenue and cost, 100 is greater than 80. So total, if profit is equal to total revenue minus total cost, 100 minus 80 would be 20. So you'd have in this case, profit is greater than 0. If I'm here, they're equal. And if I'm here, total cost at volume 2, let's call that volume 2. At volume 2, total revenue is less than total cost, so therefore profit is less than 0. So what's cool about capitation is it inverts the relationship between volume and profit. Whereas with fee-for-service, we're motivated to do more things to patients, because the more things we do to patients, the more money we make. Under capitation, it inverts the relationship, and the more things we do to patients, the less money we make. So as we actually make more money, this becomes our zone of loss, and this becomes our zone of profit. So the incentive now is to do less rather than more. All right, we're out of time, so I'm going to stop here. We'll have to finish up chapter 5 on Thursday. Then we'll move on to chapter 6. So we'll put some numbers to this next time. I realize it'll hopefully make more sense with numbers.
Thank you.
All right, thank you, Molly.
Thank you.
Thank you.